We will now discuss the solution of a problem from the section three-dimensional geometry, and this question is on the concepts of line and plane in three dimensions. This question has appeared in the joint entrance examination main held on 25th June 2022 in the morning shift. The given problem is, let Q be the mirror image of the point P with coordinates 1, 0, 1 with respect to the plane S, whose equation is x plus y plus z is equal to 5. If a line L passing through the point with coordinates 1, minus 1, minus 1 parallel to the line PQ meets the plane S at the point R, then QR square is equal to. The four options are given to us. Option A 2, option B 5, option C 7, option D 11. We have a plane denoted by S whose equation is x plus y plus z is equal to 5. And we have a point P 1, 0, 1 and its mirror image with respect to the plane S is given as the point Q. So Q is the mirror image of the point P with respect to the plane S. We are given a line L which passes through the point 1, minus 1, minus 1 and parallel to the line PQ, and which meets this plane S at a point R, then required to find QR square, that is the square of the distance between Q and R. We now discuss the solution of the problem in detail. We have the given plane S whose equation is x plus y plus z is equal to 5. Let's look at the figure. That is your plane and whose equation, the plane is denoted by S, whose equation is x plus y plus z is equal to 5. And if you have a plane ax plus by plus cz plus d is equal to 0, then the coefficients of x, y, z, that is a, b, c, are the direction ratios of that plane ax plus by plus cz plus d is equal to 0. A, b, c, which are the coefficients of x, y, z, are the direction ratios of the normal to the plane, not to the plane, as I said earlier. They are direction ratios of the normal to the plane. So in this case, x plus y plus z is equal to 5. The coefficients of x, y, z are 1, 1, 1. So they are the direction ratios of the normal to this plane S. We are given Q is the mirror image of the point P whose coordinates are 1, 0, 1 with respect to the plane S. Look here. This is the point P with coordinates 1, 0, 1. Its mirror image is Q. So that's what we have. And now the line PQ is perpendicular to this plane S. That is, PQ is normal to the plane S. And the direction ratios of the normal to the plane are 1, 1, 1 and PQ. Therefore, PQ is normal to the plane S. Therefore, the direction ratios of the PQ are 1, 1, 1. Agreed. Now, let T be the point of intersection of the line PQ and the plane S. This is T. Right. Now, given a line L that is passing through a point 1, minus 1, minus 1, and parallel to this line PQ meets the plane S at some point at a point R. So we have the point 1, minus 1, minus 1. L is passing through it, and this line L is parallel to PQ and meets the plane S at R. Right. Now, the direction ratios of, what are the direction ratios of L? Because L is parallel to PQ, the direction ratios of L is equal to the direction ratios of PQ. The direction ratios of PQ is 1, 1, 1. So therefore the direction ratios of L is 1, 1, 1. Now we can write down the equation of L. How? So L is a line passing through this point 1, minus 1, minus 1 with direction ratios 1, 1, 1. Then the equation will be x minus 1 by 1 is equal to y minus of minus 1, that is y plus 1 by 1 is equal to z minus of minus 1, that is z plus 1 by 1. So that is the equation of the line L. Now let the coordinates of R be A, B, C. Because R lies in S, ABC lies in S, therefore A, B, C satisfies the plane equation because it lies on S. So that will be A plus B plus C is equal to 5. And further, R lies on the line L. The coordinates A, B, C also satisfies the equation of the line L. So in this line L, put x is equal to A and y is equal to B, z is equal to C. It satisfies. Therefore, A minus 1 by 1 is equal to B plus 1 by 1 is equal to C plus 1 by 1. We continue in the next slide. And the story so far is this one. So the Q is the mirror image of P, and there is a point 1, minus 1, minus 1. The line L is parallel to PQ passing through this point, and the coordinates of R, we have taken it as A, B, C. Because it lies on S, it satisfies the plane equation. Therefore A plus B plus C is equal to 5. And because it lies on the line L, it satisfies the line equation. That is A minus 1 by 1 is equal to B plus 1 by 1 is equal to C plus 1 by 1. This we have already seen in the last slide. Now, these ratios A minus 1 by 1 is equal to B plus 1 by 1 is equal to C plus 1 by 1 is equal to the sum of the numerators of these ratios, that is A plus B plus C minus 1 plus 1 plus 1, that is A plus B plus C plus 1 by the sum of the elements in the denominator 1 plus 1 plus 1, and we already noted A plus B plus C is 5. This is 5 plus 1 by 5 plus 1 is 6 by 3, that is 2. Now A minus 1 by 1 is 2 means A minus 1 is 2, therefore A is equal to 3. B plus 1 by 1 is equal to 2 means B plus 1 is equal to 2, therefore B is equal to 1. C plus 1 is equal to 2 means C is equal to 1. So A is equal to 3, B is equal to 1, C is equal to 1. What are these? These are the coordinates of this point R. So the coordinates of this point R is 3, 1, 1. Now we find the length of the square of the length of PR. So that is PR square we can compute, PR square. So P to R, the distance, and ABC, note down, 311, 311. Therefore, 1 minus 3 whole square, 0 minus 1 whole square, 1 minus 1 whole square, plus plus. So this will be 4 plus 1, that is equal to 5. But we have to compute what is the square of the distance of QR. But we have found PR square. We will show now PR is equal to QR. For that, we consider two triangles. The triangle PTR, PTR, and the triangle QTR, QTR. So, triangle PTR, 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 and QTR, QTR. So, these are the two triangles. In three dimensions, you have to understand this is in 3 dimensions. Right. Now, we have PT is equal to QT. Why? Because Q is the mirror image of P. Correct? Now, TR is equal to TR. That is the common side. Right. Angle PTR, that is angle PTR, is equal to angle QTR. Each is equal to 90 degrees. Why? Because Q is the mirror image of P. Therefore, PQ is perpendicular to the plane S, and T is the point of the intersection of PQ with the S, and R lies in the same plane, and RT will be perpendicular to PQ in 3 dimensions. Yes. So therefore they are congruent. They are congruent. SAS property. SAS property, side, angle, side. Therefore, triangle PTR is congruent to QTR. Therefore, they are same in all respects. Therefore, QR, the other side, is equal to PR. But we want QR square. If you say QR square, then it will be PR square. PR square we have already computed. That is equal to 5. So that's what is wanted, and we have found QR square as 5. Let's look at our options. Our answer 5, QR square is equal to 5, appears against option B. Therefore, the answer to this question is option B. So that is the detailed discussion of the solution of the problem on line and plane from 3-dimensional geometry. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.